So let's start with Module 3, Design Communication. So first topic is engineering sketches. So we know that sketches or drawings are important because it's very easy to convey a lot of information by drawing process. It can be in the form of sketches, freehand drawings, computer designs or CAD models, or it can even be graphic images. Sketches. The use of these sketches in drawing is they can help as a launchpad for a brand new design. They help in analyzing the design, stimulate the behavior of the performance of a design, can even help to record the shape or geometry of a design. It helps to communicate ideas and communicate design to the manufacturing specialist and designers. Sketching is very powerful tool. So there are different types of sketches. First is orthographic sketches. These are those that show you a front view, a top view and a side view. Next is axonometric sketches. Axonometric sketches are those that are represented along an axis. Next is oblique sketches. It is one of the most common types of sketches where the front view is blocked and details are added. Perspective sketches are those where you choose a vanishing point and you draw projection lines from that point. We have layout drawings, design drawings. First one is layout drawing. Layout drawings are those drawings that are drawn with a scale. This is an example of layout drawings where you have to mark the scale, like what is the length, what is the height, what is the width. Next is detail drawings. Detail drawings are where you have to show the detail of every part, like what all materials are used, what are the different requirements, etc. Next is assembly drawings. Assembly drawings are those drawings that show how the individual parts or components are assembled in that product, how they fit together. So you can even include detail drawings to show the assembly of drawings of each part. Also, there are certain components that every drawing must have, such as they should have certain standard views or standard symbols, clear lettering. They must always include steady lines. They should have a title, an initial of the designer, and the date on which it was drawn. Should even include the dimensions and units. So an example of such a design that has all the above specifications. Next, communicating designs orally. So we have to communicate a design. It can even be in the form of oral presentations, reports, prototypes or models. The purpose is to inform the client and explain why or how this design was chosen. So one of an important part of the design project is report writing. So, what are some general guidelines for a technical communication? Before making a technical communication or a report, you have to know the purpose, your audience, and the content should be organized around the purpose and audience. It should be clear and precise. The pages should be designed well, think visually, and it should be written, taking into account the ethical considerations. Know your purpose, that is, you should understand what is the purpose of this report. That is the objectives and functions of the design, what it must do and what it must be. It should know the audience. Know your audience, which means it should make sure that the materials and everything is such that it meets the targeted audience. For this, you have to take time to understand the audience and make sure that the members appreciate your documents. Next is that the content should be organized around the audience and your purpose. It should not deviate from the general concepts or idea. Next is to write precisely and clearly, that is, it should be written in good writing. Everything should be clear and it should be in the form of short paragraphs so that they can be easily understood. Next is to design your pages well. They must be designed well, that is, it should be written in such a way that it is easily understandable. It should be in the form of simple and direct slides so that the readers would listen to the speaker without getting distracted. Next, think visually so that you can make use of easy visual representations by using graphic software, etc. and visual aids which will help to easily understand the presentation. Write ethically, that is, whatever presentations, whatever ideas are being done, it should be such that it gives full credit to others such as the authors wherever necessary. You should make sure that it follows all the ethical guidelines and standards. Oral presentation. What is oral presentation? Oral presentations is where you present to the crowd what is to be done. It can either be in the form of formal or informal presentations to clients, users, and technical reviewers. So, whenever making an oral presentation, it is again necessary to understand the audience, have an outline of the presentation, have appropriate supporting materials, and practice well. Knowing the audience, such as who is the audience, who all are listening, so that it is tailored to meet the audience needs. The next step is to have a clear outline. The presentation should have a clear title slide, a roadmap or outline, and then a problem statement is important that should highlight all the problems, a background material such as relevant or prior work, objectives, constraints, how can you achieve those functions and constraints and deal with those constraints, what are the other alternatives, and which design was selected, and it's also explained why this design was chosen. A demonstration of the prototype and conclusion, such as what all future work is to be done, and even suggest improvements to the design. And presentation should always include visual effects. One important tip is that it should always have a limited number of slides. Introduce your teammates, make the points clear and simple, use color skillfully and animation appropriately. Another important thing is that you have to practice well so that you get faces that are natural. Next is project report. So the process of writing a final report, this requires a well-structured approach. That is, first you should be able to determine the purpose and the audience, make a rough outline, and again review with your manager or with an academic project or with a faculty advisor. So then you have to create a topic sentence outline and review it with a team. And for each individual you can provide written assignments, written and initial draft, get reviews from managers and advisors. According to these you can revise and rewrite an initial draft, and then finally make a final version of the report and present it to the client. So what are the major sections that have to be included in the report? It should have a title, an abstract or summary of the project, an introduction and overview, a problem statement, a problem definition, other design alternatives, evaluation of the alternatives, finally results, conclusions. Next is prototypes. What are prototypes? Prototypes are basically working models of design. They are the first full-scale and functional forms of a new type of design or construction. Prototypes are to be tested in the same environments in which we are expected to function as final product. So whether to build a prototype or not, it depends on the size and type of design, the cost of building, the ease of building, and what role a prototype might play, and the acceptance of design, and the number of copies that are to be made. So in order to make a prototype, you have to know who is going to make the prototype, whether the components or parts can be bought, from where the prototype is to be made, and what is the cost. In order to construct a prototype, you can make it either 3D or 2D. Then there can be rapid prototyping by making use of CAD models. Next is model. What is a model? A model is a miniature representation of something that is used to represent a device or process. These can be in the form of paper models, computer models, or physical models. These are usually much smaller and made of different materials than the original design or artifacts, but we test it in some other controlled laboratory environments rather than from prototypes that are tested in the same environment in which our product is going to be solved, but models are made in different environments such as in a laboratory. A proof of concept. Next is proof of concept or POC. It is a model of some part of a design that can be used to test whether that concept will actually work or not. Proof of concept. It is about doing controlled experiments which should show whether a product or feature can be developed, whereas a prototype helps to show how it would be developed. Next is mathematical models. Mathematical models are important in design because they help to predict the behavior. It makes use of mathematical modeling. It's very important to include physics and mathematics. They are built on the basis of an assumption. Okay, so here the success of a mathematical model, it depends on how easily it can be used, how accurately that predicts, and how well it explains the phenomena that's being studied. Mathematical model, it depends on a set of dependent, independent variables, parameters, and other functions. Dependent variables are those that reflects the state of system. Independent variables are dimensions like time, space. Parameters are the properties or the composition, and other functions such as external influences that may act on the system. So what are the different principles of a mathematical modeling? Is that why we need it, how to use it, what we are going to find with this model, what are the different data given, and how we can assume. Mathematical models makes use of dimensions, units, such as time, length, mass. We have fundamental quantities and physical quantities. These are some things that we have learned in physics. Okay, these are like, all these things we have learned.